Alright, so we'll go over a handful of these.
I don't know. I probably did some.
Sure. I don't know where it's at.
I think some of us maybe felt some struggle with this, right? There's nothing wrong with struggling through something.
I
Okay?
just didn't do it.
One, if you struggle through it and then you start getting solutions and you start figuring things out, it's a whole lot more meaningful to you. Okay, it's rewarding. But two, if everything just came easy to us, are we changing our current level of knowledge? No. Yeah, you're just spitting back facts that you already know. That's nothing new, nothing useful. But when something is difficult, okay, how do you respond to that? Okay, it's all about the reaction. Okay, so please keep that in mind that there's going to be things in this class, guys, that you do find problematic. Okay, but obviously we will work through them. We'll get things fixed. We'll get things resolved. But the issue is when we do those things, okay, when we work through them in class and try to get things resolved, how are we taking that? Okay, is this going to be the last time that you see this problem? Okay, or we go through it in class, or you go home and you go watch the video, or you go home and say, okay, well, let's change some of these numbers. Okay, or maybe I do a quick internet search and I find a couple examples that are similar to this, and maybe I find a website that has these solutions to that problem, and I start trying to kind of muddle through it and becoming more proficient. Does that make sense? Okay. If this is the last time you see this after we go over it, you are going to miss this question on the test or quiz. Okay. Especially if you struggled with it last night. There's a lot of stuff in this course. Okay. And there's a lot of stuff in really any college level course that you take. And there's absolutely no way that we're going to see every single example possible. Okay. But there are resources out there that give you more examples. Okay. I told the last class, I said that there's going to be some heavy algebra in the stuff that we see today, but it's all algebra that you have built skills in the past to target. Things like laws of exponents, things like combining like terms and LCDs and that kind of stuff. But now we're just going to, it's going to be, in one problem, we see all those things. Okay. My fear is that some of you are going to go on to other courses and you're not going to have your algebra skills developed proficiently enough, and that when you see some of the algebra we do in one of today's questions, that one that had like ax squared minus 2a plus 1 times x plus a plus 1 equals 0, the algebra that's involved in that is pretty heavy, but that's like similar algebra that you're going to see in almost like 80 to 90% of every calculus question that you go in and see in the next course. Okay, because you're going to know, you're going to find out, I think we said this before, like question to question, they jump all over the place in calculus because they're assuming you've had 3 years of algebra, and the algebra is not the issue that we're dealing with in that course. It's the calculus. Okay, but we have to use the algebra to kind of explain the calculus. Okay, you've heard me say it's the gas that powers the engine, or the engine that makes math go is algebra. Okay, if we struggle with that, we're going to struggle with all the math. Okay, so this one here says a ball is thrown straight upward at an initial speed of 80 feet per second. It tells you what formula to use. That's nice. Okay, v sub naught, obviously. Then this is v sub naught, so we should know what we're putting in there. On tests and quizzes, I'm not going to give you that h equals negative 16t squared plus v sub naught t plus then h sub naught. I'm going to ask you to know that. But what's going on here says, when does the ball initially reach a height of 96 feet? So what we're doing, okay, we're starting here, right? Okay, and we're just going to, shoot this ball, or throw this ball straight up. Okay, it's going to reach a height, it's maximum, and it's going to fall straight back down, right? And that picture there is what I showed you yesterday, is that's the horizontal and vertical displacement of this situation. Okay, but if I think about that and record its height based off a certain time, okay, so maybe put some arbitrary times out here. If I throw this ball straight up and after 1 second record the height, okay, so the height is right there. So this is the h of t axis, and this is going to be my time axis. So then I say, okay, let's let 2 seconds elapse and record the height after 2 seconds, and maybe it's there. And I keep doing it, okay? 3 seconds, 4 seconds, 5 seconds. And I record the height after each one of those intervals. And I plot them. What I'm going to find out, guys, is that that curve is going to look something like that. It's going to be parabolic, okay? And this question here is asking you, can you figure out when it reaches certain heights, okay? So right here, they're asking, so for what t values do you develop certain h of t values, okay? And the formula that we're going to use to do this, the formula here, or the equation that models this, is the negative 16t squared. That's the acceleration due to gravity. And that's minus 1 half, times negative 1 half. Plus then your initial velocity, which we said was 80t. That's always a constant. That's always going to be negative 16t squared. Okay? But that 80t is going to change depending on what your initial velocity is. The question is, okay, so that is modeling that black curve. Okay? It provides all those infinite heights that are on that black curve. They want to know, when do you reach a specific one of those? When do you reach 96? So 96 is maybe there. Does that make sense, everybody? Okay? So that's a time, that's a height at those times, all right? At those specific times. So this, h of t, is a variable, and we're going to replace it now with 96 because that's what we're asking. When does it reach a height of 96? Okay, the only variable I'm left with now is t, so if I go through and solve that, that t must be the time in which that occurs. So now, all you have to do is just, depending on your preference for solving these quadratic equations, you can use whatever technique you want to, okay? I think this one sets itself up pretty nicely for factoring out a GCF of negative 16. Okay, if I take a negative 16 out of this, it gives me negative 5. Take a negative 16 out of this, and it gives me positive 6. Okay? Our algebra should tell us that we can divide both sides by negative 16, right? Divide both sides by negative 16, ultimately that's going to go away there. And 0 divided by negative 16 is just 0. So now does that factor? So we get t minus 2 and t minus 3 is equal to 0. So my time is 2 and my time is 3. So reaching a height of 96, so maybe right there, we get a time of 2 seconds. And then right there, we get a time of 3 seconds. Is that all right with everybody? That second one is on its descent when it's coming back down. All right. So the question is, when does the ball initially reach a height of 96 feet? So which solution do I choose? 2. That's the first one, right? Okay. Chronologically, 2 comes before 3, so that's the choice we have to make. A lot of times I get people answer 2 come 3. Okay, those are my solutions. And that tells me, 1, they didn't even read the question, or 2, they're not sure what initially means. Okay. So there will be, like on tests and quizzes, little things like that that are important. So if you write both answers, obviously you got one of the solutions right, but this is extra. This is not a solution to that question. You're going to get some points deducted because of that. The next question says, when does this thing reach 192? Okay, when does it reach a height of 192? It's the same exact question, guys, except for this 96 now becomes 192. So if that's the case, then okay, I'll go through the same exact procedure, subtracting 192 from both sides, and I get that. Looking at that, I know 192 is a multiple of 16, okay? So I'm going to factor out that negative 16 again. Gives me t squared, be a minus 5t, divide by negative 16, and that gives me 12. Okay? The 16, the negative 16 can be divided from both sides. So that's nice. So now I'm left with that, and I look at that, and it doesn't factor, right? 1 and 12, 2 and 3, 2 and 6, 3 and 4. Those are my factors of 12. None of them add to give me negative 5. So a lot of people at that stage said, impossible, can't factor it. Okay, well, you don't know that because you haven't exhausted all your factoring techniques. The quadratic formula will factor that, right? And the quadratic formula, maybe my times are irrational numbers. Maybe they incorporate radicals with them. And the techniques that I use, the practice sum technique or maybe the AC method or whatever, might not address those. Okay? So even though this doesn't factor, if you write impossible, you haven't shown me enough work to validate that answer, right? When I ask questions like this, when I don't really want a numerical response, I want, you know, maybe I do want, in this case, maybe if we do find the height of or the time, then obviously I want that work. But if there's an impossible result, and then that's what's going to happen here, this is going to be impossible. I don't just want the word impossible. I need the work to support that, okay? I might need even, or ask for maybe a sentence to explain yourself. Why do you know it's impossible? Okay, you've done the work, and you know, we've all been in a situation where we've done the work and we have no idea what that work means to us. We just write impossible and just hope that that's the right answer, right? You guys have ever been in that seat? I've done that, okay? But I explained in the last class, at some point you're going to come across a professor that doesn't care too much about whether you can just do the work, okay? I took a class through Finley a couple months ago, and the work that we were doing was pretty complex, it's called complex analysis. It's really ugly and difficult. But I would go through the calculus and go through all the procedures that I need to go through to get a solution. But if that's all I left, I didn't get any points for that question. I had to explain why I was allowed to go through that process. What theorems, what definitions, what corollaries, what postulates, all that kind of stuff that allowed me to go through that process. And then why I know that solution was true. Okay, so I had to have supporting evidence, mathematically and kind of verbally with my definitions and that kind of stuff. You might come across somebody that does that. Okay, you might come across a physics class that says, okay, find the solutions, but now tell me why those solutions work the way they are. Okay, so this is not enough. Okay, we need to go further. So I use the quadratic formula. So x is equal to the opposite of b plus or minus 25 minus 4ac, and then 2a, okay? And I instantly know, and I'm not even going to do the subtraction, but I instantly know underneath that discriminant, or within the discriminant, what kind of number am I going to get there? I'm going to get negative, okay? And the square root of negative brings in imaginary results, right? Okay? That then tells me that this is impossible. That tells me because I get a discriminant that is negative, I have no real results, meaning that that projectile never crosses the height of 192. Visually, what it would mean to us is that maybe 192 is there, okay? And my projectile never reaches that height, okay? So we might want to be able to explain that logic. It's because we bring in imaginary solutions. Okay, we have two non-real solutions here. Okay, so we write impossible there. The next three, I don't know why WebAssign does it this way. I think the next three are kind of poorly structured in regards to their order. I'm going to do these orders differently. Okay, because we've done this one. When does it reach 96? When does it reach 192? I'm going to do this one next. When does it hit the ground? Because that's an implied number, like 96 or 192. What's that implied number of when this thing hits the ground? Zero. Okay? And that's probably actually, guys, the easier of the three so far. Okay, when that becomes zero, okay, I'm going to look at the right-hand side. When there's two terms, guys, on the right-hand side, I think the first thing you want to look at is if they both have variables, then there's going to be a GCF. Okay, if maybe the ADT didn't have a variable, maybe it was just a constant, then maybe you start thinking that my GCF is just maybe a coefficient, or maybe my difference of squares might work. Okay, that process, but that's got a t in it. That's got a t in it. 16. So we'll take out negative 16t, gives me t. It's going to be what, negative 5. Okay, now this thing here, this is still a product of two things. A lot of people want to say that negative 16t is useless, okay? And you'll see a lot of questions at some point where we take out just a t, and people say, well, let's just let that one go away, we won't pay attention to it. That is a factor of this, so it has to still play a role. So we say these two numbers multiply together give me 0, so negative 16t is equal to 0, and t minus 5 is equal to 0. What's this one going to give me for t? 0. Okay, and that's almost, wasn't that expected? Okay, based on the scenario that's taking place, where did we launch this thing from? The ground, right? We launched it from 0, 0, or we threw it from 0, 0, so that solution is expected. We should have known that that was going to show up. And it's almost trivial. It almost doesn't give us really anything new, but that one does. Okay? So we start at time 0. It's obviously on the ground. We throw it. 5 seconds later, it returns to the ground. So 5 seconds there is what we're looking for on this new one that I've got to see. Okay, so what does that mean to us? All right. Well, that's 0, and that's now 5, right? Okay. And we've talked about with parabolas, there is an axis of symmetry. If you remember back talking about conic sections last year. Okay. The axis of symmetry goes through the vertex. The vertex is your highest point on your curve, right? Or it could be your lowest. It's your maximum or your minimum. Okay. A lot of times we call it your extreme value. And it is going to be the situation, the time in which that occurs, that maximum occurs, is going to be halfway in between your x-intercepts. Okay? So if one x-intercept is 0, the other one's 5, what's halfway in between? 2.5. Okay, now I'm going to write it as 5 halves because I can do that algebra a little bit easier in a moment. But 5 halves, or 2.5 seconds, is going to be when the ball reaches the highest point. Okay? You might have also remembered from last year that your vertex formula for locating the vertex formula, or vertex in a parabola, the formula we can do that is the opposite of b over 2a. Well, if I take the opposite of b, negative 80, over 2a, which would be negative 32, they both divide by 16, so it would give me negative 5 up top, and it would give me negative 2 on the bottom. Is that still 5 halves? So that tells me the time, and I used x, but our axis here is t, so there should be t's. So t is 5 half seconds. Okay, now why do I leave it as 5 half seconds? Because the third part of this asks me if this is when, so we did that one next, so this was 5 seconds, this is 5 half seconds. This one says, what is the greatest height? Well, we know now that occurs when? 2.5, right? So shouldn't I be able to take the 2.5 and plug it in for t into my equation, and that spit back then the height that's associated with 2.5? All right, so we're going to do that. So I'm going to go h, I'm going to write it as 5 halves. And hopefully you'll see the benefit of doing that. If I asked you guys to take 2.5 in your head and square it, and then multiply that by 16, can you do that real quick? Okay, but if I asked you to square 5 halves, that's 25 fourths, right? Now multiplied by 16 gets you negative 100, right? And that's pretty quick. That's much quicker than grabbing my calculator and typing. You still be typing if you had a calculator. Okay. Now I got my 80. Okay, so I'm gonna go, 40 times 5 is 200. So I got negative 100 plus 200 gives me 400. So the height that this thing reaches and its maximum is 100, what we got, feet? Okay, and it happens at 2.5 seconds. My hopes are, guys, that you see that question, even though they ask you 5 things, 5 separate parts, this question, and this one are really the same process, right? So it's really 3 different projectile questions all wrapped up into one. Okay. Any comments on that one? That clear things up for some of us? Okay. Let's see here. Let's go to a lot of people struggle with this one. And the reason I put this one on here, guys, is because it uses an aspect of what we talked about in section 1.1 or 1.2 when we started talking about linear equation. Now, this isn't a linear equation. Right now it starts off as a rational equation, but after we go through some work, we're going to find out that it turns into a quadratic equation. But the work that we go through is the exact same work that we go through if we didn't have powers of 2 in this. Does that make sense? Okay, and even if it was just all numbers, okay, no variables up there, the process is still the same. We have to multiply every one of those terms by a LCD. Okay? We have to get rid of those fractions. Okay? So in doing that, we have to decide, how do I determine what an LCD is? Remember I told you a couple days ago, or a week and a half ago, that you look at all your denominators, okay? You have to factor all your denominators, and that's what's already happened. They're already factored for us. But you then start going through and choosing all the new factors that occur. So if I look at this, I look at R. That's a new factor, right? Okay? So that has to be part of my LCD. R has to be part of my LCD. Okay? Now I go through here, and 1 minus R, is that new? That has to be part of my LCD. And then look at R squared. Okay? And R squared is R times R, right? One of those is not new. Okay? Because we already had R, right? And now we've got R squared. What was always the statement that we made? If we have the same factor, but they have varying exponents, which one do we take? The higher one. Okay? So this R to the first kind of gets replaced with that R squared instead. Because inside that R squared, we still have an R at the first, right? But inside of R to the first, we do not have an R squared. And that's kind of the issue of why we choose the larger exponent. So there's my LCD. So I'll multiply every single one of these fractions by that LCD. Key thing I think to remember when we're choosing this is that 1 minus R, that is one term. When you know what R is, that is one value. Okay, a lot of people want to put that 1 is part of my LCD and negative R is part of my LCD separately as separate factors. That's a sum or a difference, and it shows up in my LCD as a sum or a difference. Okay? So now I can go through this, and we start doing our multiplication. Okay? What's going to happen with one of these R's here and that R right there? They're going to cancel. So now it's going to leave me R times 1 minus R up top, right? Times this one, so that, and no more denominator, right? Okay. So now I'm going to go to this one. What's going to happen with the 1 minus R? 1 minus R, they cancel, so now I'm left with plus R squared times 2, so 2R squared, equals then, come over here, the R squared and the R squared is going to cancel, and I'm left with 4 times 1 minus R. Okay. Now I've gotten rid of all the fractions, right? And now you see there's some implied multiplication that you have to do here. We have to distribute here, we have to distribute there. So I get R minus R squared plus 2R squared equals 4 minus 4R, right? And now there's implied algebra there that says, well, you've got something squared, so then you got to start factoring. And if I'm going to start factoring, what do I need to get everything equal to? 0. Okay? So the nice thing is that those two things are going to just give me R squared, right? I'm going to add 4R to both sides. So it gives me positive 5R. And then I'm going to move the 4 over to be negative 4, and it gives me 0. And I look at that and say, okay, what are my factors for negative 4? They're negative 4 and 1, or negative 1 and 4, they're 2 and negative 2, and none of those add up to give me 5, right? So if none of those add up to give me 5, that product times sum technique doesn't work. What do I then turn to? Quadratic formula. Okay? So I go opposite of b, so negative 5, plus or minus b squared, so 25 minus 4, a is 1, c is negative 4, all over 2a. Okay, so that gives me 25 plus 16, right? What's 25 plus 16? 41. 41 is prime number, right? Okay, so what's nice about that is 41 doesn't have to simplify any. You see that it was a prime number, that radical doesn't go away. So that kind of convinces me then that absolutely the only way that this thing would have factored is the quadratic formula. My product in sum techniques or my AC method or anything like that would not have worked, and that's my solution. Okay. The only thing that, and you're gonna see this all year, the thing that people hate about WebAssign is that there is no plus or minus button, right? Okay. So my suggestion to you is just type one of those in. Negative 5 plus radical 41 all over 2. Then highlight that, hit Control C. Okay, so that copied it, right? Now go into the next box, hit Control V, that pastes it, and then just go back in and change the one sign that needs to be changed. And then that's as efficient or almost as quick as using a plus or minus button. Okay. Obviously on tests or quizzes you can use the plus or minus button or term symbol because it'll be all by hand. I did tell you guys that, right? All my testing quizzes, all tests for this class are written, okay? Quizzes, probably 90% of them are written. Okay, I might have 1 or 2 that are on web assignment. Is that all right? Okay. Let's see here. Try to bring my mouse with me. But my hopes are with that question, guys, you see some algebra that we've already talked about this year, right? Maybe it's addressing something different. It's addressing quadratic formula now or quadratic equations, but we saw that same algebra within linear equations. All right. This one, I think the biggest issue with this one is the fact that that first symbol is a negative sign. I think that throws a lot of people off and it causes a lot of issues with our algebra. We can address that. We can maybe distribute that through if we want to. But this problem, guys, is of quadratic form. And what I mean by that is that you have some term squared, then you have plus or minus some term to the first, and then plus or minus some constant. And a plus 1 would be my constant here. Okay. Every single time we go through this course, or a chapter in this course, there's going to be some type of factoring that we have to do with something that may not be necessarily a quadratic. It might not produce a parabola, but it might be of quadratic form, meaning that it's got something to the second power, plus or minus something to the first power, plus or minus some constant. And if that's the case, then we can use our factoring techniques with it. Okay? Now this one does get a little bit messy. I think the number one thing that people try to do is they try to multiply that x through. Okay? And the 2a plus 1. And when you do that, you end up with a total of 5 terms, and none of them combine. There's no like terms there. So then you kind of get in a roadblock and you don't know what to do. I've seen people trying to move things over and then group and stuff like that. Factor, you can't do that. When I factor, everything's got to be equal to 0. Okay? So multiplying that x through doesn't make a whole lot of sense. What's going to happen here is that we're going to use the quadratic formula. Quadratic formula always works, right? Okay. Now it might be ugly. It might be some complex algebra here, but it should always work. All right. I'm going to try to do this on the whiteboard. It's going to get kind of messy. But if I look at that, if I'm going to use the quadratic formula, would you guys agree that my a term is the coefficient for x squared? So my a term that we use in the quadratic formula is simply just a. Okay? My b term is the coefficient for the x to the first, right? So it's my 2a plus 1. But whenever I take an a, a b, or a c, don't I have to take the sign with it? So my b term is, or write it as the opposite of 2a plus 1. Okay? And my c term then, c term is a plus 1. If we can keep that straight, okay, we should be able to plug that in now to our quadratic formula and get results. Remember, our quadratic formula is this. Okay. When you're doing this, be thoughtful, be slow. Okay, don't try to rush through things because you're going to miss a sign. You're going to miss, combining like terms, that type of thing. So just be careful. Okay. So this is opposite of b, right? Well, this is b. The opposite of that's going to negate that negative, isn't it? So at the beginning, I'm just going to have 2a plus 1. Plus or minus then. Okay. Now I'm going to go with my b squared. Okay. Well, b is this thing. This class was a lot faster than the first one. I will finish it. I'll do this problem on a separate video, and I'll put that on my website, and you guys can look through that on your own. No new homework this evening. Now, that being said, no new homework. If we start